And welcome to this lesson on solving linear equations, which is going to serve as an introduction to the topic. So without much delay, let's get started. So first thing we need to do is get a little bit of terminology out of the way. So what we're doing when we're finding a unknown in an algebraic equation is we're finding the value of normally a letter, which is often called x. But before we start to look at how we find that value of x, we need to know a little bit about how we write different forms of x and what we do to manipulate them. So first of all, if we've got 2x, this means 2 lots of x. So 2 times x, which looks a bit confusing because the multiplication sign looks a bit like an x. But that's why we use an x next to the letter without the actual multiplication sign to avoid that confusion. So 2x means 2 times x. So 5x therefore means 5 times x. And anything else in front of the x would mean that times x. So 12x would be 12 times x and so forth. Next one, x over 4 means x divided by 4. So this means x divided by 4. And again, you can see we don't need the division symbol because we just write it over 4 and that implies the same thing. So x over 7 means x divided by 7. And that serves as the same way of writing x divided by 7 but with the x over 7 instead. Now, as we said earlier, the aim when we're solving a linear equation is to get the letter by itself. So my final answer is typically going to look like x equals some value or some value equals x. Normally, it's going to be this first one here. So x equals and then a number immediately afterwards. And then at the bottom, I've got a reminder there. We always want to check our answer and then we can tick once we've done our check, because we will know that we are right or wrong, depending on what we are doing. If we check and we're wrong, we can go back and modify it. So the first thing we're going to look at is solving one-step equations. So as the name gives away, one-step equations involve one manipulation to get the final answer. So first thing I want to do is I want you to have a go at this one here. Whatever way you think you need to do this question, have a go at it. So pause the video and have a go. Okay, so you probably, for this question, you probably got that the value of x was equal to 3. Now, there are lots of different ways to do this. Now, the first way that most people look at this is they use a cover-up method. So they imagine that x wasn't there. So they say something plus x equals 10. Oh yes, that something must have been 3. Now that is absolutely fine for questions such as this, but that's not going to help us on the more tricky ones. So we need a little bit more of a formal way to work it out. So this is the formal way to work these out. So the formal way is we want x to be by itself, so we need to remove anything which is after it, or indeed maybe before it or underneath it. So here we've got a plus 7 after it. So we need to remove the plus 7. And to remove the plus 7, we do the opposite or the inverse of plus 7, which is minus 7. Now we don't just do it to one side because equations must always balance like an old-fashioned pan balance scale. So here we must minus 7 also from the other side. So always what we do to the left-hand side of the equal sign, we must do to the right-hand side of the equal sign. So now we can see that we've now got x, the plus 7 and the minus 7 have cancelled themselves out. And now we're left with x equals 3, which is the same answer as the cover-up method, but we've got a bit more of a method and a bit more of a routine of how to do it. Let's look at this one now. X plus 4 plus 5 equals 8. So the first thing I need to remove is the thing which is stopping me finding the x, which is this plus 5. So I need to do the opposite of that, which is minus 5. Remember, not just from the left-hand side, but to balance it, also from the right-hand side. Now that's going to cancel out. So now I'm left with x equals an 8 minus 5 equals 3. Now let me check my answer, because this is the proper example now. So I know now, I think that x is 3, so I can do 3 plus 5, and does that equal 8? It does indeed, so I know that I am correct. Here are a couple for you to have a go at, so pause the video and have a go at these ones, and then I'll go through the answers. Okay, I'm back again. So what we should do on this first one is we must minus 8 from both sides. That's going to result in the 8's cancelling. Then we've got x equals 11 minus 8 is 3. Let me just check my answer to prove that I'm right. 3 plus 8 equals 11. That is true, so I know that I am correct. The next question, I need to remove the plus 19, so I minus 19 from both sides. The 19s are going to cancel, so I've now got x equals, again, funnily enough, it is a single digit number, which is 2. So x equals 2 now. So it's going to be 2 plus 19 for my check. 2 plus 19 does indeed equal 21, so I know that I am correct. Next one-step equation, I've got a subtraction this time. So x take away 3 equals 11. So first thing I'm going to do is I'm going to do the opposite of take away 3, which is add 3, not just to the left-hand side, but also to the right, so that it balances. I've now got x, the plus and the minus will cancel, because they're both 3's. And then 11 plus 3 does indeed equal 14. Let me just check my work. 14 take away 3 equals 11. I know that I'm correct. Have a go at these two. Pause the video and then I will go through the answers shortly. Okay, let's go through these answers. So the first one, I need to remove the minus 4 by plussing 4 to both sides. That now equals x. The plus 4 and the minus 4 will cancel. Equals 13. Let me just check my work. 13 take away 4 does actually equal 9. So that is correct. Next one, I need to get rid of a minus 12, so I add 12 onto both sides, and that cancels there. So I'm now left with x equals 64. Now let's check to see whether I'm right. 64 take away 12 equals, I think it equals 52. If you need to use a little bit of a column method to prove these, then just do so. Next one, on the one-step equations, we've got this for the first time now. Remember earlier we said that 2x represents 2 times by x. So if I've got 2 times x, to do the opposite of this, I divide both sides by 2. I divide both sides by 2. So opposites cancel, remember? So divide by 2 and times by 2 cancel each other out. And then I'm left with x equals 18 divided by 2 does indeed equal 9. Let's check my working. 2 times x is actually 2 times 9. And does that equal 18? It certainly does. And that must be correct. Here are a couple for you to have a try. Pause the video and have a go at these two, please. Right, let's go through these answers. So this first one, the opposite of times 3 is divide by 3. So I do that to both sides. The 3's are going to cancel because they are opposites. And x equals 7. Let me just check my answer. 3 times by 7 does equal 21. So I am correct. Next one, 6x equals 42. I need to divide both sides by 6. And that means that the 6's will cancel. And x equals 7. 7 times 6 is 42, I believe. So we can now do 6 times by 7 equals, it does equal 42, so I know that I'm correct. And the last one in the one-step equation section of this lesson is, let's have a look at this one. X over 4, remember, means x divided by 4. We have been practicing using this division in the previous set of questions, so we're familiar with this now. So the opposite of divide by 4 is multiply by 4, and we must do that to both sides. So times 4 and divide by 4 will cancel each other. So we're left with x equals 12 times 4 is 48. Let's just check my answer to prove that I'm right. 48 divided by 4 equals, now we might need a bus stop method on this if we need to check it. Might not know our 4 times table up that far. So 4 into 4 goes once, 4 into 8 goes twice. The answer is 12. I know that I'm correct. I can move on. And for the last time in this section, have a go at pausing the video and attempting these 2 questions. Right, let's go through these. So the opposite of divide by 2 is times by 2. So we do that on both sides. So the 2's cancel. I'm left with x equals 16. Let's just check my working out. 16 divided by 2 equals 8. And that's exactly what I wanted. And the next one, the opposite of divide by 5 is times by 5. So I multiply both sides by 5. The 5's will cancel, and x indeed equals 100. Just check my answer. 100 divided by 5 equals 20. That is correct. That's what I expected, so I'm correct. And that's it for the first section on one-step equations. So let's take it a step further and move on to two-step equations where we double the amount of marks, but we don't actually double the amount of difficulty, thankfully. We just build on what we've just done. So first on, let's have a look at 2 examples before I give you some to have a try at. So now we've got x and a number on the left-hand side, sorry. So we've got 2x plus 6 equals 18. Now you might think, what do we get rid of first? Because we need to get rid of this 2 in front of the x. And we need to get rid of the 6 as well to relieve the x by itself. Now generally, we get rid of the thing which is plus or minus from the x's. So we're going to get rid of this plus 6 first of all. So let's get rid of this plus 6. So to get rid of a plus 6, I do the opposite. And I minus 6 from both sides. Now look for a moment where I minus the 6 from. That is important. I did not minus the 6 from underneath the 2x. I minus the 6 from underneath the plus 6. So now I've got 2x remaining. Plus 6 and minus 6 have gone. So 2x equals 18 take away 6 equals 12. And now I've got 2x equals 12, so the opposite of times by 2 is divide by 2. And then the 2's are going to cancel, so I'm left with x equals 6. Now let's check my working to prove that I'm right. So I've got 2 times by 6, which is plus 6. So 2 times 6 is 12. 12 plus 6 does indeed equal 18, so I know that I must be correct. Let's have a look at example 2. So remember, the first thing that we get rid of is whatever is plus or minus from the end of the equation. So we're going to get rid of the minus 12 by adding 12 onto both sides. So now we've got 3x, the plus 12 and the minus 12 have cancelled, and that equals 33. 21 plus 12 is 33. I now need to divide both sides by this 3, which is the opposite of times by 3. Now the 3's are going to cancel, so x equals 33 divided by 3 is 11. Let me just check my working. 3 times by 11 take away 12 is the same as 33 take away 12. 33 take away 12 does actually equal 21, so I know that I'm correct. Here are a couple for you to have a go at, so pause the video and have a go at these 2. Right, let's have a go at these questions. So first of all, we're going to add 3 onto both sides. So that cancels. And now I've got 3x equals 24. And then I just need to reverse this times by 3 by dividing both sides by 3. And then we get 3 cancels with 3. X equals 24 divided by 3 is 8. Let me just do my check. 3 times by 8, take away 3. 3 times 8 is 24. 24 take away 3 is 21. I know that I must be correct. Question number 2. First of all, I get rid of the 5 by taking away 5 from both sides. So that means that I'm left with 9x plus 5 and minus 5 have gone equals 45. Now, I just need to remove the times by 9 by dividing both sides by 9. So 9 and 9 will cancel. So I've got x equals 45 divided by 9, which is 5. Let's just check to see whether I'm right. 9 times 5 plus 5. 9 times 5 is 45. 45 plus 5 does equal 50. So I'm right and I can move on. Next set of examples then. So we've got a division involved this time, but we've also got still that same thing about a number being plus or minus from the end. So that rule still applies. We get rid of the plus or minus number first. So what I'm going to do is I'm going to get rid of this minus 3 by adding 3 onto both sides. So if I add 3 onto both sides, I get that 3 cancelling. So the x and the divide by 2 move down. Nothing happened to them, that's why. And that equals 13 plus 3 is 16. Now I need to do the opposite of divide by 2, which is multiply by 2 on both sides. So I'm left with now, the 2's will cancel. So x equals 16 times 2 is 32. Let's check my working. 32 divided by 2. Take away 3. Well, 32 divided by 2 is 16. 16 take away 3 equals 13. So I must be correct. So x must be 32. Next example. The first thing we get rid of is the number which is plus or minus from the end, which is on this occasion the plus 12. So I minus 12 from both sides. So the 12's cancel. So I'm left with x divided by 3 equals 5. And now I must get rid of the 3 by multiplying both sides by 3. So now 3's will cancel. And then x equals 5 times 3 is 15. Now what I need to do is check my answer. So I know that, or I think it's 15. So 15 over 3 plus 12. 15 over 3 is 5. 5 plus 12 does actually equal 17. So I know that I'm correct. As before, have a go at these 2 questions by pausing the video. Okay, let's have a go at this question here firstly. So the first thing we get rid of is minus 4 from each side. And that's going to result in the 4's cancelling and x over 5 just dropping down, and that equals 5. Now I must multiply both sides by 5 to remove that divide by 5 on the denominator. And now I've got x equals 5 times 5 is 25. Let me just do my check. 25 divided by 5 plus 4. Well, 25 divided by 5 is 5. 5 plus 4 actually equals 9, which is what I expected it to be. So that must be, that must be correct. That must be correct. So have a go at the next one. The first thing I get rid of is the minus 2. So I plus 2 to both sides. And then that's going to result in the plus 2 and the minus 2 cancelling each other out. So now I've got x over 4 equals 4. We multiply both sides now by 4, look. That means that the 4's cancel. So x equals 4 times 4 is 16. Let's test my answer to see whether I'm right. 16 divided by 4, take away 2, is the same as 16 divided by 4 is 4. 4 take away 2 equals 2. That was what I expected, so I am correct. On to the next one. So it looks the same as the other ones. Let's see what's different about this one, because there's something which will catch you out. But let's have a look, see what the difference is. So first of all, I'll get rid of the number which is plus or minus from the end. So this much is the same. So I've got 16 taken away from each side. So I've got 4x. The 16's cancel. So I've got 4x equals 2. Now I need to divide both sides by 4 to remove that 4 from the front. So now I've got x equals 2 over 4. Now I'm going to simplify this fraction. We can see our answer comes out as a fraction now. So half the top and half the bottom to get 1 over 2, which is a half. Or I could write it as 0.5. In fact, at this stage, either one of these answers are correct. In fact, 2 over 4 might be accepted if they don't specify that it needs to be simplified. But I think a half or 0.5 is what we would really expect there. Next example. First thing I need to get rid of is the plus 3. Oh, on that first one, sorry, let's just check our answer. I just want to check, we always want to be checking our answers. So we're doing 4 times by a half plus 16. We know 4 times a half is the same as half of 4. So 2 plus 16 equals 18. So I must be correct. Next one, we take away 3 from both sides first. And then we're left with the 3's cancel, so we're left with 2x equals 27. And now we got to find out by dividing by both sides by 2 what the value of x is. So the 2's will cancel, so x equals 27 divided by 2 is half of 27. Now, might be a bit tricky. The method that I usually use is half of 20 is 10, half of 7 is 3.5. Oops. Half of 7 is 3.5. We put those together, we get 13.5. Now let's test our answer. So 2 times by 13.5, well, we know that's the same as 27 plus 3. So we've got 27 plus 3 equals 30. I must be correct. Have a go at these two for yourselves and pause the video. Okay, let's have a look at these. So first of all, I'm going to plus 3 to both sides. That cancels, so I'm left with 2x equals 11. Now I need to divide both sides by 2. And we get cancels, x equals 5.5. Let's check my answer. 2 times by 5.5 minus 3. Now 2 times 5.5 is 11. 11 minus 3 equals 8. I must be correct, so I can move on. Next one, minus 10 from both sides. The 10's are going to cancel, so 4x equals 10. Now I divide both sides by 4. The 4's will cancel, so x equals 10 divided by 4, which is the same as 5 over 2, which is the same as 2.5. Again, if you leave it as 5 over 2, you'll probably still get all of the marks. Next one, let's have a look at what happens when we've got a division and then a number at the end. Now, not much different from what we just practiced. We still get rid of the number which is plus or minus from the end. So, minus 10, minus 10. So, oh, this one looks a bit different all of a sudden. We can see we've got 3 take away 10. There's something interesting going to happen here. Let's have a look. So, x over 2 plus 10 and minus 10 have gone. And that equals 3 take away 10, which is minus 7. So I've got a minus number this time, so we have to deal with our negative numbers. We're trying this without a calculator, of course, so it's good practice on that. So now I need to multiply both sides by 2 to remove that denominator of 2. So now x equals minus 14, which is the final answer, but I need to check it. So minus 14 divided by 2 plus 10. So minus 14 divided by 2 is minus 7. Minus 7 plus 10 equals 3. I can move on knowing I'm correct. Next example. I need to minus 9 from both sides here first. So the 9's cancel. So I've now got x over 4 equals 7 take away 9 is minus 2. I need to now multiply both sides by 4. And I've now got that cancels with that. Then x equals minus 8. Let's test my answer. Minus 8 over 4 plus 9 equals, I'll just find it out first. So minus 8 over 4 is minus 2. Minus 2 plus 9 does indeed equal 7. Must be correct. Pause the video and have a go at these few questions, please. Okay, let's have a look at these answers. So minus 14 from both sides first. And that's going to cancel with there. So I've now got x over 3 equals minus 4. And then multiply both sides by 3. Now, minus 3. So x equals minus 12. Let's test my answer. Minus 12 over 3 plus 14 equals 10. No, not equals 10. We don't know it equals 10 yet. We need to prove that. So minus 4 plus 14. Now we know it equals 10. And that must be correct. Next one. Minus 6 from both sides firstly. And that leaves us with x over 5 equals minus 2. So now multiply both sides by 5. The 5's cancel, and then we've got x equals minus 10. Let's test my answer. Minus 10 divided by 5 plus 6 is minus 2 plus 6 equals 4. So I must be correct. Next question. We've got a little bit of difference this time. It's just the order of things. So just to look at this, if I've got a red ball in my left hand and a green ball in my right hand, and let's say that the value of those two balls is worth 14. We don't know what the value of the red is or the value of the green is. But then if I swap hands, so if I all of a sudden say that my green is now in the other hand and the red is now in the other hand, they would still equal 14. So it doesn't matter which way round we're holding them, they still have the same value. Now algebra has the same property. So 5 plus 4x is the same as 4x plus 5. Now take it from me, without much further example at this stage, that if we don't change this around, it will add problems to us later on. So if we see the x written separately second, then write the x at the start. Just, it makes the maths a bit easier further down the line for when you move on to more tricky and complex situations. So now I've got this. Everything else is straightforward for us, I would hope. So we can cancel the 5's here. And we've now got 4x equals 12. And then divide both sides by 4, divide by 4, and then we get cancels, x equals 12 divided by 4 is 3. Let's just check my answer. 5 plus 4 times 3, so 5 plus 4 times 3 is 12, 5 plus 12 equals 17. It's got to be correct, so I can move on. Have a go at these two questions, pause the video and have a go. Right, let's have a look at this. So first thing I need to do is I'm going to rewrite my question in a more appropriate way. So 3x plus 1 equals 22. Now I can start to solve it by minusing 1 from both sides. The 1s will cancel. So now I've got 3x equals 21. Now I can divide each side by 3, which is the opposite of times by 3. That's gone. So now x equals 21 divided by 3 is 7. Let's check my answer. 1 plus 3 times 7 is the same as 1 plus 21, which we know is 22. That's what I expected. It is correct. Next one, we need to write it in a more appropriate manner first. So 5x plus 6 equals 21. Now let's minus 6 from both sides. So now we've got 5x equals 15, and then we can divide each side now by 5. Divide by 5, and then we've got cancels. We've got x equals 3. So 15 divided by 5 is equal to 3. Let's check my answer. 6 plus 5 times 3 is the same as 6 plus 15, which is 21, so I know that I'm correct. And on to the last set of questions for today. A little similar to the ones when we talked about the red and the orange balls holding in our hands and then switching around. It's the same with the equal sign. We don't really like the x's to be by themselves on the right hand side. We like them to be on the left. So I would be very tempted to write 3x plus 6 equals 15. And now I need to solve it like normal, so I can take 6 from both sides. That's going to result in 3x equals 9, and then I can then divide each side by 3. Divide by 3. 3's cancel, so x equals 3. Let's check my answer by substituting back in. So 3 times by 3 plus 6. 3 times 3 is 9. 9 plus 6 does indeed equal 15, so I must be correct. And for the last time in this session, pause the video and have a go at these questions. All right, for the last time, let's go through these. So I'm going to write them in a more appropriate manner first. So 3x minus 1 equals 20. Now I'm going to add 1 to both sides to get 3x, that's cancelled, equals 21. And then we divide each side by 3. So therefore x is cancelled, sorry, 3 is cancelled, x equals 7. Let's test my answer. 3 times by 7, take away 1 is 21, take away 1 is 20. That must be correct. And the last one, write it in a more appropriate manner first. 9x minus 6 equals 30. Let's get rid of the minus 6 from both sides by adding 6. And we now get 9x equals 36. And then divide each side by 9. Divide each side by 9. That cancels with that. So x equals 4. Let's check my answer. 9 times by 4, take away 6. 9 times 4 is 36. 36 times 6, take away 6 is 30. That's correct. So I can tick for the last time. So thank you very much. That's been a session on solving linear equations, and we'll move on to more complex ones in a future lesson. Thank you very much.